going to go ahead and get started, folks. My name is Eric Wolf, and I'm going to show you how to take what Mike just presented with prototyping and convert it into a production run of circuit boards. We're calling this Prototype to Production, Ideas to Tangible Reality, and this is a process overview, and I cannot stress enough that this is a high-level overview. Unfortunately, if you were coming here looking to learn the nitty-gritty of how to use schematic capture software, that's not the, I'm going to show you a little bit of that, but that's not the entire intention of this, but I will give you the tools necessary to go elsewhere to learn how to do that on your own. I could easily take up a full day showing you how to do schematic capture and board layout. So I'm basically going to give you a general overview of the end-to-end, and there's a lot of things that you need to decide for yourself. So I'm going to give you the tools to do that, and it will be wonderful. My name is Eric Wolf, like I said. I'm N5EBW, and my website is baconfatlabs.com, and the slogan is the best use of fat since bacon. That's what my father always told me. So jokingly and lovingly, of course. Next slide, please. About me, I'm a computer programmer by trade. I'm a hardware programmer by hobby, meaning I like to put components together to make useful circuits. My other hobbies include ham radio, go figure. Woodworking, I have all 10 fingers still. Metalworking, I've been doing that for a couple of years. I haven't done much of that since high school. I'm getting back into that. But I'm looking at starting metalworking in my garage with lathe and job shop, mill operation, stuff like that. It's fun. Shooting and reloading and a little bit of gunsmithing mixed in there. That's where the metal work crosses over. I'm all about the pew 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 lifestyle. Home brewing, meaning not homebrew circuitry, but homebrew drinking. And angering family members with the amount of hobbies to time ratio I have. And I have too many more hobbies to list, and I don't want to mention them for further angering them. As you might imagine, circuit board design and programming are the natural glue that kind of bonds some of these hobbies together. Even with the home brewing, I made a PID controller for the kegerator that I'm building. I designed a PID controller for it. And there's a lot of them out there. They're really cheap. I just did it to see if I could do it. Next slide, please. And I just want to mention that the results of the home brewing, I generally don't mix them with the other things. It kind of goes along with the having 10 fingers still thing. Next slide, please. Some assumptions about me. Click. This is where my clicker comes in handy. I'm not perfect. In fact, you might say I fail a lot. One of the mottos that I live by is fail early and fail often. That's how you learn. Next, please. I'm not a formal engineer. I will not even pretend to be a formal engineer. I am, however, well versed in the smoke test. For the purposes of my designs, my tolerance criteria includes, did it catch on fire? Is it getting hot? Because that might eventually catch on fire. And it functions, but is it pretty? It's kind of like Mike was saying, you know, you build some ugly stuff, but you put it into an enclosure, and it's the greatest thing in the world. A lot of my stuff doesn't ever make it into an enclosure. It's kind of modular for, you know, that you stick in larger things. That's still hidden, but, you know, I try to at least make things match what's already there. Next, please. The methods in this presentation are a reflection of my personal experience. Your mileage might vary. That's why there's so many options out there for schematic capture and layout. Next, please. Many other people wrote the book on this stuff, and I just read it, and I'm in no way an expert. So I just want to be really upfront about that. Next, please. You have seen part one of this presentation, hopefully. If you have not, it's okay. This presentation will be available on YouTube in addition to Mike's, and for anything that I reference back to him, they're not totally dependent on each other. But there may be some stuff that you may want to review from his presentation after HamCom. So both of those will be available on YouTube as well after this is over, so you can go back through. Next, please. Have some knowledge of electronics or ideas you wish to bring to fruition, or at least be willing to learn some basic electronics to make your schematic feasible. Next, please. And this is the most important one, that you have the restraint necessary to not throw things at me if you disagree with this presentation. It's very important. Thank you. So kind of like Mike's paper slide where he's driving in the car and an idea comes to him and he jots it down really, really quickly. This is what I call a BevNap. And has anybody ever heard the term BevNap before? BevNap schematic. I call it BevNap CAD. This is usually when I'm sitting down to eat a meal or I'm out with friends, sometimes with the group. We will come up with these ideas and we'll sketch them out and the only thing handy is a beverage napkin. Of course, you always have a pen, but you never have paper. So the closest thing is a beverage napkin. So the first thing you need to do, you need to make the napkin useful and cross out Bambi's number. Your wife will not be pleased anyway. Next slide, please. So kind of the way this went is we were meeting one day with the group, and I looked at Mike and I said, let's get together and do a HamCom centric circuit board project. And he says, I don't know, are you sure we can do it in time? And of course, I'm always optimistic about these things until the very last minute. And I looked at him and said, no sweat, super easy, plenty of time. What could possibly go wrong? And Mike said,
Next week or the week before that?
I think we started a few months ago, but we were in crunch time. We were pretty much in panic mode for the last month. And real panic mode this past week, especially since we both had some other things going on as well. And we wanted to set we wanted to gear this toward having a unit cost of around $2, just as kind of a fun little introduction, end to end for this presentation. And of course, these are famous last words. Next, please. So the first thing you need to do when you have that schematic on a beverage napkin and you want to, and assuming you've already prototyped this on some of the perf board or Manhattan style or ugly style or whatever, breadboarding rather even, and you want to make a formal circuit board out of it, assuming you've actually tested it, which sometimes I'm kind of bad about because prototyping has gotten really cheap. You need to import that into what's called schematic capture and board layout software. Most of the time you'll just hear it mentioned as schematic capture. I want to just note here that the fancy trade name of schematic capture and board layout is electronic design automation. You'll hear it referred to as EDA, whatever. It's all the same thing. There are two varieties that you can get, the free and the not free. You'll notice I've listed the platforms that these run on, Windows, Unix, Linux, both. Sorry, Mac guys, I don't know enough about Mac to be able to make that call, so I apologize. But from what I understand, a lot of this is compatible with Mac. And you'll just see they're color coded for what they can do, Windows, Unix, Linux, or both. And so you've got dip, trace, eagle, PCB, fritzing, so on and so forth. And for purchase, there are several more at the bottom. Purchasing schematic capture software, if you're a hobbyist, can be a little daunting as well because the hobbyist version of some of these can be $500. So, assuming you stay away from commercial, a lot of times you can do light versions of this software that are very, very capable and will do the same thing as the base model of the purchase software will do. If you click the slide. Yeah, Altium is really, really nice, but I'm not sure it's worth $10,000. And yeah, and you've probably heard, if you've heard anything about schematic capture software, you've probably heard of CADSoft's Eagle. That's what I use. It seems to be the most prevalent around the hobbyist market. There's abundant support. The development is very, very active. I'm getting upgrades at least bare minimum every quarter. I get an upgrade notice for Eagle. The support is abundant. The user communities are phenomenal. There's a community on Element 14. Has anybody heard of element14.com? Okay, so it's not very new. Yeah, they own it now, and that's why I was going to point out that they own the software now, so that's why it's been so phenomenal. But you can go onto their forum, and they have a guy, Richard from Element 14. He'll answer my question within 12 hours if I get stuck. And these are not easy questions that I throw him because I've been using Eagle for so long, and it's phenomenal. I couldn't be happier with it. Yes.
Have they changed the license restrictions on using the free version? Because from what I recall reading, you couldn't
It's still true. You can't use the light version for commercial product. As long as you stick to hobbyist stuff and you have no, like if you're doing a design run for like, if you're doing like a club project, for instance, and you're basically looking to recoup cost for what you're doing, and you're not selling the boards, but you're just making kits for internal use or something like that, then it's no big deal. So.
Do they still have a free version of their current?
Yes. Eagle has a free version of their current software. It's around 7.3, yeah.
I think the last one I checked, they quit doing the free version.
I'll have to check on that, but I'm pretty sure that it's still free.
Okay.
Yeah.
Yeah, mine gives me a prompt to upgrade. I'm using the free version, and 8.7.3 is the latest.
Yeah.
Okay.
Yes.
Is the free version studied? Does it not do certain things?
It's limited. It locks you to like, for instance, 2 layers and a certain board area. I think the board area is like 4x4, 4 inches by 4. But you can fit an awful lot of circuit on 4x4. That said, I have hit it occasionally. And
you could build more than one board.
you could build more than one and modularize and stack them. It's very popular. Like for instance, like the Arduino. The big thing right now is shields for the Arduino where they stack up, and the Pi is no different. And so it's
one sheet on your
one sheet. Yep.
Which, when you're building a complicated circuit,
It can get confusing. Yeah. Well, a lot of hobbyist stuff is going to just be one sheet, and
I thought so too.
yeah. I've hit it too, but I do some real complicated stuff. But
Also ran into a problem with 3x4 too.
yeah. Okay, next slide, please. Now, what you see on the right-hand side is what we end up with when we import it into a schematic capture tool. And what you see on the left is what we started with, of course. This looks nice, but I'm sure you kind of want to see how we generally got here. I'm going to go into that a little bit, but like I said, it's not going to be an end-to-end all-inclusive. And in fact, it's going to be, very basic. Next slide, please. So what you see here, and I apologize, I had to cram everything onto one slide, so it's kind of small. But what you see here is Eagle at the top, and there's an Add Parts button on the left-hand side of Eagle, and I've highlighted that where it is on the toolbar. And the way you actually make things in schematic capture within Eagle is everything is predefined in a library of parts. And there are hundreds and hundreds of libraries that you can choose from in Eagle. And you basically just go through the tree and select which one you want. There's 2 general things you need to be concerned with here. There's the schematic symbol, but there's also the board footprint, and they're linked together in Eagle in something called a device. And I can't tell you how many times that's bitten me. Choosing the correct schematic symbol, but ultimately the wrong layout, and I'll get it back from prototyping, and I'll be like, this is not what I wanted, even though it's staring at me, clear as day on the layout tool. It could be a couple millimeters off, and something on the footprint not fit, but it's not readily apparent sometimes when you look at it virtualized on a computer. So just be very mindful of that when you're picking your parts. So, and some of these are vendor facilitated, like Microchip facilitates some of their library. Analog Devices has a big library. Of course, a lot of the solid state logic stuff, like your LM chips and everything, those are pre-built into libraries within Eagle. So if you needed like a NAND chip or something like that, you could just go reference it by its 4-digit number, and it'll say, do you want the 74HC, do you want the 74LS, blah 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 blah, what footprint do you want, and pick it, and you can basically click OK, and it'll show up on your board. You just drop it on your board and move it wherever you want in the schematic. Okay, so that's for parts addition. I see a question maybe. Okay, next.
I'm just saying that the most important thing about all these capture software is the footprint.
Yes.
The footprint is everything.
Yes.
If you don't have a good footprint, you'll waste all your money.
Yes.
So the very first thing that you should do is print the footprint out on a 1-to-1, put your part on top of it,
Yep.
and make sure that it fits.
Yep, and that's a good thing. That's what I've come to do most of the time now. And sometimes, I was working with very, very, very small components like surface mount stuff, and they look like, you know, little fleas. There's, you know, like stereo microscope stuff where, you know, you need to place it, you know, with tweezers under a stereo microscope small. So sometimes, you know, when you get down to that low, you know, it's a little hard to do, but for the most part, it's a good idea to print out your board 1-to-1 and make sure that your components match up with the footprints. It's a good suggestion, thank you.
What I do is I create my own library, and once I confirm that the part is actually good, I put that part in my library, so I know all my parts are approved. Whereas everybody else's, they won't guarantee that you're approved.
Yeah, and that's what you're seeing here. I've got my library open, and I'm actually designing a custom part here. All this is a you know, a piezo element with 2 leads coming off of it. So all I needed was, you know, 2 little pads to connect to, and, you know, a piezo, you know, schematic symbol that I have a custom library, and I do sort of the same thing. You know, I'll use a lot of the same parts over and over again, you know, because they're trusted and they work, you know, why not? Yes.
So is the problem here when you're thinking about these things lining up is that maybe the generic little thing you're doing has 10th-inch spacing, but yours has 3/10.
Yes. Yes.
And unless you custom design it as that's the 3/10.
Yep.
Then, and you don't realize until it's finished, then you can't build.
Exactly. Yeah, and I've run into that before too. You know, I was talking earlier, push connectors that mated 2 boards together. The pitch was just a hair off, and it was, you know, too far forward, you know, in the design, and the leads, since they were up under it, you know, there were surface mount. You plop the component down on there, and you wait, or you know, heat the board up until the reflow happens, and that's not apparent until, you know, because all the leads are up under it. You can't necessarily see it at the time, you know, but it's wrong. So, and you're testing it, but this component is here, this component is here, and why is this not? Oh, I don't have connectivity on this layer to this layer. So you find out that you don't have a component that's properly reflowed to the board because the footprint is mismatched. And so what you're seeing here, basically what I wanted to show you with this slide is, for any custom parts that you do have, and you will run into that, I do run into that often, where you need something custom, you'll need to go into the library and define a new part. And that a new part is defined in Eagle by taking a schematic symbol, and you can lay that out in the schematic symbol editor, and then you go to the footprint editor, and basically this is the result of my schematic symbol editor, and this is my footprint editor. And then when I create my device, I link them 2 together. You can't see it very well because of the resolution of the projector, but I link, like, say, there's a green circle here and a green circle here, which is telling Eagle that this is my pin 1 and this is my pin 2. And on my layout, I'll have a corresponding pad 1 and pad 2. Well, it doesn't know that pin 1 goes to pad 1 and pad 2 goes to pin 2 unless you tell it that they're logically linked together. So when you create a device profile, you have to go in here and say, yes, this pad links with or this gate links with this gate. You know, or this gate links with this pin, and this gate links with this pin. And it's got some error checking and stuff. It'll tell you, you know, sometimes if, you know, something's not quite right after you connect everything together. It's not that intuitive. It's not that helpful when it does its error checking, but it helps sometimes. But basically what I wanted to show you here is that anything is really possible if you need to define a new part. Next slide, please. And putting it all together, this is after you've placed all your components onto the board. This is actually not how you will import something into schematic capture. So I'm kind of telling you a small fib, and I apologize, but it was the only way to make it flow into the presentation. What will generally happen is you will plop a component onto the board, and you will go to the wire tool, which is this tool right here, and you will connect that component to another one that's on the board, and whatever else it needs to go to. And then you'll go get another part and you'll drop it on the board, and you'll use the wire tool to connect that, and so on and so forth until you've got everything the way you want it. Next, please. And after all our wires connected, this is, you know, just to kind of show you how everything links together between the components and the wire tool. There's something called a bus tool with an Eagle. I don't use it a whole lot because it's a little, on a large scale it can be confusing. Even on a small scale it can be confusing. The bus tool, basically you lay a blue line down and you name the bus, and you can run wires to it. and then you can pull wires from it to another component within the system. But you know, if you're troubleshooting something like that, like say I connected all 8 of these wires to a bus somewhere, and that's totally possible in Eagle, and then you came off of that bus to their corresponding components. If you're trying to troubleshoot this, all you're seeing is 8 wires going to a line and then a line going to other components, and that's not really helpful. So I generally don't use the bus tool in favor of the wire tool so that I can, print it out and trace it, make, handwritten notations on the schematic when it breaks, where it breaks, what works, what doesn't. Yes?
Does Eagle have any kind of auto alignment button that kind of gets everything looking pretty in case it's all squeezed up in one corner or something?
It does.
Or either that, or can you manually move things? Like,
Oh, yeah.
if I click that chip and move it, where all the pins stay connected appropriately.
Yeah, they'll stay connected. What'll happen, like for instance, if I pick this up and moved it, it would take, say I moved it left. Okay, if I move this here, it doesn't move them all, parallel to each other. It will take and angle them all off like this, and then you'd have to drag this over. But what you can do, you could take the group tool. It's right there. You can draw a box around it, and then it's like control right click. It will highlight them all to move, and you can move them all at once. That's incredibly helpful, more so on the layout side of things, because a lot of times you'll have holes for a certain footprint that you're looking to center up on the drawing, and you take everything and you highlight it, and you just want to justify it across the rest of your silkscreen layer or what have you. And that's incredibly helpful in layout. It makes things pretty unschematic, but I'm ever so slightly type A, and I kind of do them one at a time for the most part. So good question, thank you. Next slide, please. Okay, so we have a working schematic on the left-hand side for the board that we would like to produce. Now we're going to go into what we call board layout. And I'm not going to show you, again, very much about board layout because I could literally spend all day talking about board layout. It is so complex. And it's one of those things where you can learn enough to get by. You can learn a whole lot. Just learn as much as you need to know to begin with, and kind of build on that information as you get more into the tool set. Or you could figure out that, hey, I don't like this tool set. I'm going to jump over to KiCad or something. So just, I'm just going to give you a general overview of the stuff, like I said, that I use and what works for me. So we're going to talk, a little bit about board layout. And what that is, it's a virtual view of all the layers, routed traces, component locations, dimensions, silk screens, labels, and many, many other things. Literally many other things. And of course, it doesn't come out looking like that on the right. And there's a few things you have to do, like everything. Next slide, please. In fact, what you get and what you end up with, like I said, you have to do everything. What you get on the left-hand side, and you can't see this again, I apologize. When I was doing the presentation, it wasn't apparent the poor resolution of the projector. But what you get on the left is what you start out with. When you go from schematic capture and you click on the board icon, which is up here, I believe, and that's saying create a board from this schematic. So what Eagle does, it runs a job and it plops you into the board layout editor, and all it does, it gives you all of the components that you've selected from the library and placed on the tool, and it connects each component electrically with yellow lines, and what those are called, if you don't connect them, they're considered what's called air wires, which means if you've got a bunch of pads and you do not put any traces on the circuit board and you want to assemble this board, you stand there with a spool of wire and you plug from wire to wire and you solder both wires together to get connectivity. And that's what they call air wires. And you can certainly do it that way. It's not really, if you're going to design a circuit board, I don't recommend doing it that way, but you can. It's possible. Air wires are also useful if you're doing things, if you've done a board layout and you can't efficiently route a trace because you have no room and you have to make an air wire connectivity. Like from here, from one corner of the board to the other corner of the board, you need to do like a stub lead. That's an extreme scenario, of course. But say you don't have room to route a trace and you need to take like just like a small jumper wire or something like that and run it across, the circuit board on the top. You saw that in you rip open a VCR, I guarantee you'll see 30 air wires, connecting some of the components, together in that scenario. That was when 2-layer design was more prevalent than 4-layer design. Of course, now you've got 4-layer and up boards where you have internal traces. It gives you a lot more options. There's a faint gray line here. It's just a generic box that Eagle gives you. And what that is saying, that's your board. Those are your exterior dimensions of the board layout. You can make that any size up that you want for your design. But keeping in mind that if you have the light version or like a standard version, you are subject to the design restraints that are placed within that version of Eagle.
That's the maximum size board that you can get?
Yes, yes. So anything in there goes, and if you have a small circuit board like this, I think that's, I want to say it's 1 inch something by, the lower side of 2 inches. I don't remember. Like I said, we don't have that much time to cover it. We have 50 minutes for this presentation. As much as I would love to sit here and talk to you about layout, because it's actually one of my very favorite things. We just don't have time to cover it. Next slide, please. So jumping past the big layout portion, say you have a working layout that you've put together on the left-hand side here, and this is the custom layout for our project on HamCom. You see we've added some silkscreen lettering for from Dream to Design, HamCom 2015, baconfatlabs.com. I have added all of my components and routed all of my traces the way that I want them. It's pretty. And also you'll notice there's a QR code here that we placed on the image, and I'll tell you what that's about later. So we have a virtual layout of what we think our circuit board should look like, so let's get them produced. Next slide, please. So I'm going to talk a little bit about prototyping services, and you really want to prototype something before you make a production run. I can't stress that enough. It's a lot cheaper than making a run of 100 and realizing that 5 holes on this component are too small and your component won't fit in there. So you have to tackle them with a pair of needle nose pliers to widen the hole. True story. That was the infancy in circuit board design. I botched a run of 100 and I will never live it down. Some of the prototyping services that I've come across are Express PCB, Gold Phoenix, OSH Park, and Screaming Circuits. And just like with the amount of choices you have with EDA software, you have even more choices for prototyping services. Literally everybody that does production runs will do a prototype for you. It's just a matter of what pricing model that you want to adhere to, what design rules. Like say you have a really small trace. Some board shops aren't set up to do that. They can only do traces, I think it's 7 mils wide, 6 mils now, okay. So it's not very often I get down to 7 mils or 6 mils, but that is a consideration if you've got, a lot of finite traces. You need to be aware of that. You need to be aware of the accepted design files. Like a lot of prototyping services will take an Eagle board file, for instance, direct from you, and it's no big deal. But a lot of them won't. And that's a consideration that you need to take when you're doing design files. Fortunately, I will show you how to take that one step further. Next slide, please.
Well, Express PCB takes Gerber files?
Everybody takes Gerber files, yeah.
Well, I thought that they have
Yeah.
their own layout design that you can download.
Yeah, they have that batch PCB or something like that. Or no, it's like 123 PCB or something. I haven't used Express PCB in years, but they're still around, and they're popular among some people. They're expensive, but a lot of people that still think stick with what you know. So.
Do you ever use Advanced Surface?
I have not, no. I use mainly OSH Park, and I think a lot of people do now. You're nodding your head. I know, I can tell, he's not a noob. So in the hobby circuit board realm, it's the clear favorite right now, and everybody, you go to a hobby electronics website, like Adafruit, you hear a little more Freed talking about OSH Park. Any kind of robotics room. In fact, we'll go into a little bit of the history of this in another slide. This is what I use for my designs. Next slide, please. And I'm going to talk a little bit about OSH Park because it is what I use and I have personal experience with them. That's not to say I don't like other services, but this is what I use. OSH Park grew out of a small prototyping service called Lane PCB, and it was founded by a guy named James Neal, and Lane is Neal spelled backwards. to service the prototyping needs of a robotics group called DorkBot PDX. I don't know if anybody's ever heard of DorkBot. Okay. So the service has grown by several orders of magnitude since Lane did it, because it caught on and said, hey, you can do my boards for this amount and you can turn them around pretty quickly, so we're going to use you. So OSH Park also absorbed batch PCB, which used to be it used to be intermingled with SparkFun. And SparkFun Electronics and batch PCB have parted ways, and batch PCB got absorbed into OSH Park. Some things about OSH Park is it's a fixed cost. It's $5 per square inch, which, if you've got, a circuit that's, 1 inch by 2 inches wide, that's, 2 square inches, it'll cost you $10. And you get 3 copies of that circuit for $10. So that is real inexpensive.
Yeah, you also get 2 layers.
2 layers.
Solder mask.
Yep.
Silk screen, plated holes.
Yep.
And gold edition.
Yeah, and I'm going, yeah, I was going to say, you can have it in any color you want as long as it's purple with gold traces. Kind of like the Ford, you can have your Model T in any color you want as long as it's black. Yes, I've been nothing but happy with them. Multiple board file types are accepted. They accept Eagle board files and the Gerber files in zip format, which I'm going to go into in a minute.
So that square inches on the complete peripheral, in other words, if you have cutouts, it's actually the...
Yeah, I think I'm not exactly sure what their algorithm does, but I think they just take the outermost, they'll connect,
Yeah, it's the outer of your.
Yeah.
The little gray square that
Yeah, and it's been so cheap for me not to haggle, for honestly. So I don't know what their algorithm. I don't know if it takes into account cutouts, but I think what they do, it's extreme outer dimensions of the circuit board.
Do they do cutouts and then say I need to have it?
Yeah, they'll do cutouts on your dimension layer. Like if you plop a cutout on your dimension layer and you want to, say I wanted to get rid of that QR code and have a big circle or a big square right in the center of my board that goes all the way through without anything on it. I could certainly, go to my dimension layer and dimension it out, and they'll cut it out. But they'll still take the outer board dimensions, and I believe that's because that's a loss to them at that point. Like if they're cutting out, the outer dimensions, that's considered yours anyway because they can't use it on the panel for anything else. Yes.
they won't do V group, it's all.
Yeah, they won't. It's all, and yeah, that is the thing. I get V grooves on my production boards, but my prototypes are snaps from OSH Park, and that's no big deal because I'm prototyping. But yes.
Will they put mounting holes on it?
If you design them into the layout, yes, and you could do that. There's a whole layer for holes. You just specify it like you would a regular, a regular drill. Like say you put a pad on there. All that is really is a, it's a coated hole basically on it.
Larger hole, like
Yeah.
440 or something.
Yes, they will. They'll route out the holes for 440. I do that all the time.
You can either make it plated through or you can
Yeah, and a lot of times what I'll do, then that's a good point. A lot of times what I will do, I will tie the mounting holes to the ground plane because the mounting holes will be locked into a metal chassis, and I want to incorporate that metal chassis for ground shielding. So what I'll do, I'll make those electrically connected to ground, and just use the screws to. I get crazy with it. Sometimes I will leave. I'll leave the traces uncoated. Sometimes I'll leave them in there so that they're uncoated, and we'll take solder so that it's got a little bit of grip for the solder, to the lug to go down onto and so forth.
And they don't charge you higher price for multiple sized holes in the board?
No. No, it's a fixed price for area. Now, I can't say that that's the case for all design services. In fact, my prototype or my production run company, if you have over 300 holes on your board design, there's an upcharge. But 300 holes is a lot of holes, and that's not,
It's small.
yeah. Okay, I think that's it. Next slide, please. This is just a little bit of what the interface looks like. I mean, you could go out to oshpark.com, but I wanted to show you how intuitive the website actually is to use. All you do, you click on this bar right here. It pops up a dialog box, to accept your file, just like any kind of other upload utility would. And while it's processing your file, you tell it what your project name and description and your email address is. By the way, that's the only place in the whole presentation where my email address is.
The file that you upload is just your board file.
It's just your board file. And if you're using another, if you're using like another EDA software suite, you can supply them with a zip file full of Gerbers, and they'll take that as well. When you upload it though, it'll say it'll detected, a 2-layer board, with these dimensions. It looks like it's 1.33 by 1.82 inches is the dimensions of our board. And it'll give you that figure in millimeters too. I'm just reading this out because you can't see it, but I know it. And it tells you the total cost. It was $12.05 for 3 copies of that board, which is insanely cheap for prototyping. It's, no disrespect at all to, breadboarding or Manhattan style or ugly, because they certainly have their place. $12 beats me sitting around for 3 days trying to, glue pads and use tools. And I'm very mechanically inclined, and I'm very detail oriented, but with really, really small stuff, that gets the best of me, and I get frustrated very easily trying to do that. So sometimes it's just easier for me to put out the small, footprint stuff, in a quasi production, board to play with, and I can hack on that all I want. And if I fouled that up, I'm only out $12. And if I want to try it again with another beta run, I can always go back and order 3 more, and they'll be here in 2 weeks. Which, for my purposes, I don't do anything rush anyway. And you can see also just one more thing. Also not apparent, thank you, resolution. This is a 2-dimensional rendering of what it takes from your board layout file, front and back, what your silk screen, what your traces, what your component layout looks like, everything is incorporated on that file. Pay attention to that.
Yes.
Really, pay attention to that. And I'll tell you why in a bit. Next, please.
Eric, there's several of the board manufacturers that now give you this free FDM tool that you can run your files through it, and it'll tell you if it's manufacturable.
Yeah, the Gerber viewers. And I don't cover Gerber viewers because I don't use them that often, because they give me the preview and
A lot of the board
yeah.
manufacturers, no, that's a free.
Yes, and when I talk about, they give you the tool to do the quality assurance of the board. My board manufacturer does something special where what they do, assuming that it passes their design rules, they will render the Gerbers for you. They will stick them all into a PDF document and mail it to you for proofing before they actually manufacture it. And so I haven't had to do that in a while, but I've had to do that before.
Well, Advanced Circuits does that.
Yes, they do. Yeah, and that's a very good company. Any other questions? And this is what you get in the mail. You can always tell when you get an OSH Park mail because it's always in a purple bubble mailer, and it's always the same size. It's super cool. I get giddy when I get these in the mail. It's like, I know what I'm doing tonight. We were supposed to go to the park. No. Okay, maybe after you go to bed. Okay. Next slide, please. Okay, Gerber what? I'm going to talk a little bit about Gerber files because we've hinted on them earlier, but for a lot of people in the audience, they may not know what Gerber files are. The Gerber format is it's a standard in the industry as a file type that is accepted by all board manufacturers, and if Gerber format's not accepted, then they probably won't be in business much longer. It's a binary format. It's called the 247X specification, I think. I'm not, it might 274X, 247, I'm not sure, I'm sorry. 274, okay, thank you. It's a universal industry standard. Many circuit board manufacturers are starting to accept the Eagle board files by default because that's what a lot of people are using. But there are a lot that don't, and you do need to furnish your own Gerber files. And I've just listed a couple of the software suites. A lot of the software suites will generate different file extensions for their Gerbers, but you always generally get the same things when you produce them. Like, if I have a .cmp file in Eagle, that's my top copper layer. And, say if I manufacture that in OrCAD, they have a simpler naming convention, which is .top. So. And these are just differences between EDA suites, isn't that special. And like I said, the extension of a file in the Gerber archive denotes exactly what the file does, but these can be vendor specific. They can be very vendor specific. as far as the EDA suite goes. The contents are based on the specification, but your file extension is not. Next slide, please. You evil wizard, what is this Gerber sorcery you speak of? Like I said, every piece of EDA software either allows you to save your layout as Gerbers or export Gerber files.
Not baby food.
Not baby food. You do not want to eat it. Ends badly every time. More and more things are going to towards exporting them in favor of the application, retaining a proprietary file. And what I mean by that is KiCad saves your file in Eshima. Eagle will, and that's your schematic, not your board file. What is KiCad's board file equivalent? Anyway, they have their own proprietary file format. Eagle saves it in .brd, which is basically, it is obfuscated to XML for the most part. A lot of things have gone to XML formatting with a proprietary cover on it. But they're all proprietary. So generally the way you do it, you run your Eagle board file through what's called a CAM job processor. And somebody had brought up earlier about somebody having a CNC machine to do your board file etching with. I'm not sure who it was. But somebody brought up that you could take it to your friend with a CNC circuit board etching machine. And you would go through the same methodology when you did that. You would go through a CAM job processor. You would use a different CAM job to generate that file, but you would still use the same methodology you use to produce Gerbers, where you go, pick out the CAM job file and you run the job to produce what you need to give to that person. So basically, this is the goes outa portion of Eagle, where you're taking it and making it useful to something else, like a board manufacturer or a CNC machine or something like that. And the process, and it's pretty, you can user design these CAM jobs. They're not locked into what you get with the tool by any means. So if you need something special and you want to learn how to, write a CAM job, go nuts. I generally don't. Like I said, they're based on, and you were correct with the 274x specification, because the CAM job you pull up for this is going to be gerb274x.cam. And what that's saying, generate 274x compliant Gerber files. And they have a corresponding job. Say you do 4 layers, which you can't do in Eagle Light, but if you did do 4 layers, then there's a corresponding job called Gerber 274x-4layer.cam. And that'll get you the same to the same place, except it will incorporate more internal layers into the job. So you take all that and you zip it up and you give it to the board manufacturer. You say, here. And you either give them a board file or you give them the zip file full of Gerbers. And from there, it's up to them. Next slide, please. This is just an informational slide on when I generated Gerbers with Eagle. My board name was Untitled 2. It was very unique. But these are some, CMP, my top copper layer, CRC, CRS, GPI, so on and so forth. These are just different, files that the Gerber job will generate. And this is what you'll take and zip up and send off to the manufacturer.
That's a curious question, because I just happen to use DevTrace, which is, another type of program that we talked about.
Yeah.
All of my files come out with the GBR.
Yeah.
I mean, it's like top GBR, bottom
Yep,
GBR.
and that's what I was going when I was talking earlier about the extensions being vendor specific.
So there's some manufacturers that want certain extensions.
Yes.
Just renaming the extension.
You just rename it, because the internal is the standard binary format. You can just rename the extension that they're looking for, and that's perfectly fine to do.
I found a real cheap board manufacturer in China.
Really? Yeah, most of them are, and that's something I wanted to bring up, but it's kind of a sore spot. Most of your board manufacturers will be overseas. When I talk about production manufacturers, I'll go into that a little bit. Next slide, please.
Where's Eagle?
The Eagle is based out of Germany, but it's a software company.
I didn't mean Eagle, I meant the...
I think OSA's part. I think that they're domestic. I think they're in Oregon. Yeah.
Their board is domestic now.
Yeah.
OSA's part is a,
There's a couple
Yeah.
batching services that use in Phoenix.
Yeah.
that means they don't do the boards.
Yeah, because they can panel them up on 100 square inch pieces.
Oh, okay.
Yeah. So now we're going to talk about production board manufacturers. These are, like I said, these are just a few. There's hundreds of them out there, but these are just a few of the ones who I've even heard about or have experience with. I've heard about Olemex. I've heard about Sierra. I have not used Olemex or Sierra. I've used Express PCB, PCB Cart, PCB Express, and Screaming Circuits. One thing to note about Screaming Circuits is they are domestic as well. I had I don't want to say a client, but a friend who was looking to do something, but he did not want his design files going overseas for whatever concern, as you might imagine, because there's a lot of counterfeit stuff, being stolen overseas. So he wanted them domestically produced. Screaming Circuits for a domestically produced company is very reasonable, extremely reasonable. So if you have a requirement that your boards be domestic, I suggest maybe look at them a little bit.
Advanced Circuits is in Colorado.
Colorado, okay. And a lot of these are prototypers too, you're going to notice. Like, PCB Cart will give you prototypes, but they're not very cheap. Screaming Circuits will give you prototypes. I tried to list things on here that were not as cheap for prototyping as they were for production, just to kind of delineate it a little bit. And they'll have different requirements and design rules as well. They have minimum hole sizes, trace sizes, whatever. Next slide, please. PCB Cart is the manufacturer that I actually use. Like I said, I'm going to highlight whatever I'm using, just as my experience goes. I've been using them for 8 years now. I haven't had a single problem. I have had a problem, but it wasn't their fault. It's always been my fault because of something I glanced over or some footprint that I, didn't figure correctly or something like that when I got the run back. I won't go much more into that. Next, please.
So if you're doing the production with them, they don't do prototype, they do production.
They do prototyping as well, but it's not as cheap as the ones that I was showing you. They will all generally do a prototyping component. It's just a matter of what you're willing to pay for it.
So if you were to order 500 boards, would they send you a first couple of them to check, or how would you make sure?
Generally, they give you the run in one fell swoop. You can order them to be tested, which I don't know exactly how they test them. I think they do some kind of pogo pin thing. They do movable pogo pins and connectivity checks. It doesn't cost me anything. They do the free checking. Yeah. Yeah, because they want you to be happy with it because it takes, 2 weeks.
But because of all the size layout issues that you mentioned earlier,
Yeah.
it sounds like you'd better get it tested.
Check
it and solder it up and make sure it's okay.
Yeah, that's what I do. I prototype through OSH Park, and then once I've got a layout that I'm happy with, I'll send it off to production.
And you don't have a problem with any file format being accepted differently or anything, as long as you don't screw
PCB Cart takes BRD files.
up. Okay.
Yeah, I haven't had to generate Gerbers in a while. I mean, I can. I'm perfectly capable of that.
So it's in the same file.
Yeah, exactly. I send the board file to OSH Park, and then I send it to PCB Cart. So this is just a website breakdown of what you'll expect to find. They give you a free quotation, of course, on the left, and you can pick and choose which options you want. Of course, like things like silver traces are going to cost you more, gold traces are going to cost you more, lots of cutouts will cost you more. Anything that adds to the overall baseline machining time or whatever that they factored into the process. Like if they have to use a smaller tool, if you have lower than 6 mil traces, for instance. They have to use different tooling to make that happen, so there's an upcharge for that in the quotation. So for 100 boards, it costs $114.87, so 11.5 cents per board. But you tack on shipping charges, and it's a bit more. This is PCB Cart.
I guess it also depends on the thickness of your layers.
Yeah, and you can specify the thickness. You can specify both your copper weight and your substrate weight. That your board substrate. They give you a price matrix too. This is what I find pretty neat. Like they show you, I wanted to order 100, so they tell me, how much it's going to cost me. It'll cost me, 70 cents if I wait 12 days for them to produce it. 75 cents if I'm impatient and want it in 8. They'll give you the price break, and you'll notice as you go up, you order more, the less the unit costs to produce. Next slide, please. And I just want to point out, it's not uncommon to see typos on web pages from foreign circuit board companies. Like they misspelled matrix as matrix. Next slide, please. And then after a price quotation, you can pay through PayPal, pick your shipping. It's just like buying something on eBay almost. What I wanted to highlight though, there is a one-time tooling cost, which was like $36.67 or something. And then there's the shipping cost. So your first board run is going to cost you a little bit because they have to do a one-time tooling fee. Assuming you're going to do multiples of this board run, that one-time tooling fee goes, when you reorder, it goes away on the next run. So the first run that I produced was costing me $145 for a bare board, and that's factoring tooling cost and shipping into that base model price. Excuse me. If I reordered this, it drops to $109, and that's with shipping factored into that, because I showed you it was 70 cents plus the shipping. You know, I break it down per board, and it's $109 per board. Next, please. Yeah.
What size board was that?
It was 1.33 inches by 1.87 inches. Yeah. Yeah. So we went from a bev nap, and these are the way our circuit boards looked like when they came back from PCB cart. They come back in shrink wrap, bubble wrap packages for mailing. I always use DHL because it's usually a cheaper shipper, and I'm not usually in a hurry to get it. I have horrendous problems with FedEx. I apologize to anybody in the audience who works for FedEx. So we get a DHL package, and I get giddy when I get a DHL package too, because it's basically the only thing that I order that comes through DHL these days. So now we have a tangible product from our idea. We went from a beverage napkin to a circuit board. Next slide, please. And then we have a bill of materials. We have to source our parts. I'm not going to go too much into this because I know we're probably running over, if not over.
Does Eagle have a bill of materials built in?
They do. You can generate a bill of materials from Eagle. I don't use it a whole lot because I design a lot of my parts, and I'm not terribly good at keeping the documentation up for that. Yeah.
For small runs, are there any companies that you can just, in China, that you can send the bill of materials and say,
Yes, PCB cart will do that. If you send them the materials, either that or have them source it for you.
right?
They will build them for you. Of course, that's an additional cost. And it's generally prohibitive for me if I'm trying to keep a price point. Because most of my stuff is in kit form for, you know, the Ham Club or something like that they're going to build anyway.
Is this like not really practical below like 500 dollars or something? Just because they have to paint those, like if you position a switch or something,
Yeah.
well, what if they don't have it? They got to order it.
So they can either order it. Usually you can send them the parts that they can't source. Yes. We actually had Screaming Circuits assemble boards for us. It's something I just signed an NDA for, so I apologize. I can't go into it. But we had them, you know, source the parts and assemble it. And we came out ahead. It would have taken forever to do it manually. So don't leave your package materials out of the BOM, because they cost money too. Anti-static bags are expensive. You know, consider, you know, 100 of them cost you, you know, $8 on eBay, but that's $8. You know, that's 8 cents, you know, for a run of 100, you know, that's 8 cents, and your cost just goes up by, you know, if you're trying to keep it under $2, that's, you know, your cost goes up, what is, you know, 4%. Yeah, thank you. End of the day, no math.
Do you
Yes.
normally concern yourself very much with enclosures? Because
I do.
especially
And enclosures are horribly expensive. That's why Mike was saying if you're going to do your own thing and build your own enclosures, you can often come out ahead. Because I've had something that I just designed was a 4-inch by 3-inch circuit board in a matching enclosure, and the enclosures were costing $12 a piece. Plus a laser etched acrylic front end panel was adding to that cost as well.
is that when you say cut, is a custom made enclosure with all the cutouts and everything for any?
It was actually a stock enclosure that we found at Fry's. And I was going to mention, if you do need a stock enclosure, Context Engineering is a great company to get your enclosures from. Context Engineering. And their technical support department is great. I called them right up. I have a person that I can call there now. And, you know, I was like, I need some extra screws for this. Okay, I'll go ahead and send you a sample of that too, no problem. You know, so I get it, you know, it didn't cost me anything. Very happy. But yes, enclosures are horrifically expensive if you're looking to source it. A lot of times, you know, what people are doing with like Raspberry Pis and stuff, they'll make, you know, enclosures out of acrylic that are like, they're like puzzle connected pieces where you've got like, I don't know if anybody woodworks, but you've got like not dovetail joints, but box joints. Thank you. They box joint the thing together, and they put CA glue in between to lock it in place, and which is super glue for the most part. And that works pretty well. It's just one of the many options. You can put your enclosure in anything you want. I put things together, stuck it in the static bag, and zipped it up to leave it running and isolated from everything.
On the cases, I ran across a firm the other day, I don't know if you've heard of it, called protocase.com.
Heard of Protocase? I've never used them though.
Never used it?
I've never used them. No.
They have a design tool that's free, that you can design the whole case.
Yeah, I use Pinocchio a lot of times. That's kind of out of scope for this presentation, but a lot of my acrylic faceplates and stuff like that. Pinocchio is the prototyping service, and I design them in a free 2D tool called Inkscape. And Inkscape is a free thing. It does a lot of the stuff that Illustrator does that I would concern myself with, but it's free, and it works just as well. So why not? I don't have $55 to chuck at a Adobe subscription every month.
So does that say that they take SVG files?
They take SVG files, yes, and they do 3D printing as well. Just check them out if you're interested in that stuff. It's Pinocchio, Pinocchio.com. They do 3D printing. They do metal cutting, all kinds of stuff. Anything else?
How do I find this presentation on YouTube?
They told me they would put it on the HamCom website once I posted it. So keep looking for the HamCom website. There's a download that I'm going to make available on my website, plus I will blog about it on my website if you can't find it there. baconfatlabs.com. Yeah, Ponoko.com. Next slide, just real quick. Sourcing parts, I'm going to glance over this because most of you know how to source your own parts. eBay is an option. Beware if you're doing production runs that you want to recreate eBay. eBay is very temporary in nature, and and I've been sent counterfeit parts through eBay too.
Yes.
Next slide, please. So these are the parts that we got for our kit runs. Since this is a limited run, we use Mauser and eBay. I like Mauser because it's next day from Fort Worth, and I'd rather pay Texas state sales tax than Thief River Falls, Minnesota state sales tax that DigiKey has. Pretty much. Next slide, please.
You can always trust the parts from Mauser.
Yes, exactly, and their customer service is great.
They're good guys.
Yes. A project of even this magnitude, you need to keep your financial considerations in mind, because if you run out of money, you can't bring your idea to reality. If you run out of funding to make it a reality, you will feel like you are walking under this dark, dark cloud. Next slide, please. By the way, those kits we made, they're for you. We produced a run of 100 to give out at HamCom. Please pick one up on your way out. Have fun with it. It's not a serious kit by any means, and you will see that when you read the assembly instructions. This QR code, if you scan this QR code with your smartphone or whatever apparatus you are using these days for QR code scanning, there is a link to the presentations embedded in that QR code. There's also assembly instructions for the kit. Mike's presentation, my presentation, as well as the assembly instructions are all going to be in that zip file that you download from the QR code. So,
Who funded this production? You got a barrel for us to drop $1 in?
don't worry about it, please.
Oh, man.
My gift to you. It's my way of making up for the rushed presentation.
What do they add sell? Anything?
No, it's my personal blog. It's where I put all of my hodgepodge of nothingness.
I found it last week. It's kind of entertaining.
Oh, what were you looking?
I was just trying to find it. You'll do a little prepping before I come to the.
Oh, okay. All right. Yeah, it's hodgepodge of nothing. There's a little bit of everything on there. I wrote an article. I got addicted to an MMO game last summer. I wrote about that. I got into home brewing. I wrote about that. I did an article on cull lumber from Home Depot. Cull lumber.
Trash lumber.
Yeah, trash lumber and using it for projects. Things like that. Shooting gong targets, whatever. I don't get to do it much, but when I write articles, I try to make them something entertaining. So, next slide, please. And you'll probably end up on that website. Is when I put the video on YouTube, I'll probably embed it on the website too. Any more questions? First of all, thank you so much. I really enjoy presenting for y'all.
Do your applications or things that you made ever concern yourself with another expensive issue, which is battery power?
Yeah, like the kits take 9-volt snaps. 9-volt battery will easily cost you $2 a piece. Just kind of the way I figured it was the easiest way to put the kit together. I can't source 9-volt batteries for everybody, unfortunately, but
Not things like, you haven't dealt with like lipos or anything like that.
I've dealt with lipos, and I think we were looking to do something UAV related for lipo battery because they're so compact now. The problem with lipos is they tend to have stability issues at altitude. So, yes.
The board you're getting us, what does it do?
It's a Morse code oscillator.
You didn't describe it, the whole thing.
It was in the I kind of wanted that to be a surprise. It actually says it on the board. It says, please enjoy this Morse code oscillator on us.
Is there a speaker?
There is a piezo element. Yes. Yes. All it is, you stick it in the board. It resonates on 2200 hertz, which is pretty mid-range for hearing-ish, because some people have no low range and have no upper range.
What do you use for a key?
Whatever you want.
Okay. So
Yeah. No, there are 2 holes in the board where you come off of it. You put whatever wires you want on there, and you can connect a key to that. You could take 2 wires, stick them together and beep, beep, beep. You can leave it continuous, and the instructions actually say, annoy your friends, family members, and pets. Life is good. Next slide, please. I think that was it. Okay, thank you.